we're going to be looking at proportional reasoning, and the method we're going to use to solve this is by graphing. The overall expectation is to solve problems involving proportional reasoning, and the specific expectation is to make comparisons using unit rates, and we're going to use dynamic software to help us construct this. Okay, so here's our inquiry type question. We'll read through it once, and then we'll highlight what is important. Two stores are advertising specials on oranges. Store A has this price, store B has this price. Oranges are sold individually. How much less would 30 oranges cost at store B than store A? Okay, so this is a more difficult type question. Let's highlight what we think is important to start. Two stores that are advertising specials on oranges. Store A's rate and store B's rate. They're sold individually. That's going to be important to us. Okay. How much less would 30 oranges cost at store A than store B? This whole last sentence is relatively important. So we have our comparisons here. Since we're going to be using graphing, and we're going to use some software for it, I need to build an equation from these two questions. So let's build an equation starting with store A. We'll do store A in red. Okay. So what it says here is we know we have a direct variation relationship. We need to build y equals m times x type equation, okay? And m is our rate, and our rate would really be depending on how many oranges we bought, okay? So we're looking at the price per, we've read as orange, okay? And per means the value of 1. So we have our values here for store A, and we know that there's 8 oranges at a cost of $4.24. We need to reduce it for our rate to the value of 1 orange. So in order to do that, we need to divide our value of 8 by the number 8. So we'll divide it by 8 to get a relationship that's reducing. And because we divided oranges by 8, we're going to have to divide the amount it costs by 8 also. So let's take out our calculator. Okay, and here we go. We have 4.24 divided by the value of 8, 53 cents. So it looks like store A costs 53 cents per orange, right? Now this 53 cents is our rate. So let's build this equation before we even start on store B. So y is equal to 0.53 x in this case, okay? So that's for store A. Great, we've built our first one. We'll do the same process for our store B, which we'll do in green. Again, same type of relationship. We know we're going to be building a y equals m times x. The reason being is because if I don't buy any oranges, I don't pay any money. And we want the rate to be the same in order to compare them. We need money per orange. I guess it's all in green in this case. Okay, so m is our rate, just like we had before. So store B, let's take our information. They sell 12, and I'm just going to use the letter O for oranges there. 12 oranges for $5.52. Okay, again, because our rate is per orange, per being the value of 1, we need 12 to reduce to the value of 1. So how much for 1 orange? Well, we have to divide by 12 in that case. And because we divided oranges by 12, we'll have to divide our dollar amount by 12 again. So let's take out our calculator once again. Oops, I scrolled up. That is 5.52, so $5.52 divided by our 12 gives us a rate of 46 cents. So this store, it costs 46 cents per orange, okay? So for store B, our equation would read y is equal to 0.46 times x, okay? And we should define that x is our oranges because it is our independent variable, right? Depending on oranges, that's what our cost is going to change. So x was our oranges, and that's important when we come to graphing. We know our x-axis will represent oranges, and our y-axis will represent money. I guess I could have used better colors to set this up. Okay, so that's our total costs. So let's go to our graphing type software here to take a look at what this would look. All right, so we go to our software here, and store 1 we said was red. So here's our relationship we've built. We know our x-axis needs to get up to at least 30, and I've built it so our y-axis has a parameter that's at least 20, because that looks like that's above what our cost will be. Store B is 46 cents per orange we buy. So you can see the green line is lower than the red line, and as we go on, that gap seems to widen more and more, so our savings increases. So with our software, we need to know at 30 oranges what the cost is per store. So I'm actually going to put X, because X represents oranges, equals 30. And look at this. I get a line that runs through both. So instead of me following up and trying to figure out the numbers on this specific software, I'm just going to click where they intersect each other. So 30 oranges at the red line, that's $15.90. 30 oranges at the green line, which is store B, is $13.80. So the difference in cost is actually the difference in our Y values. So $15.90 subtract $13.80. So I'm going to go back, okay, and we knew store A that we just read over there was $15.90 for, and this is again always for 30 oranges, and store B we said was $13.80. I'm just going to go back and double check, make sure those are right. 1590, 1380, perfect. And we're going to subtract these values. So when we subtract these values, okay, we know there's a 10 cents and $2 difference. So we would be saving $2.10 if we decided to purchase our oranges at store B instead of store A. If you'd like to see other ways on how to solve this question, just check out our other playlists on proportional reasoning.